We're going to talk about IP backbone security. It's going to be related to the internet, but also to your corporate network. So we're going to talk basically about the following different topics. We'll introduce a little bit what's going on the internet at the moment. You know, after 9/11, a lot of people started to say, okay, the internet is really critical infrastructure, and what are we going to do to protect it? Because we need to protect it to run our business. So we're going to talk about this topic, and then we're going to move ahead and talk about the different routing protocols. That is BGP for the external gateway routing protocols, and also the ones that you are running on your corporate network are usually OSPF and also ISIS, which is kind of an old protocol, but a lot of people are starting to use it on corporate networks and even ISPs. After that, I will hand over to Sebastian, and he's going to talk about DDoS detection, especially using functionalities that are inside Cisco routers. This functionality is called NetFlow. Basically, NetFlow is a tool inside routers that does network traffic accounting that can help you to detect what's going on your network. And after that, we'll talk about MPLS and IPv6. A lot of companies at the moment, especially the ones that are going for voice over IP and so on, that need kind of introduce quality of service end-to-end in the network, are pushing MPLS even to the edge. So we're going to talk a little bit about it. Basically, the whole talk is going to be about attack and defense, what's going on, how to protect against it. And we'll try to put some templates on it, on what's going on, how to fix it, how it's broken, and if it cannot be fixed, well, how to mitigate the risks that are related to that. We are not going to talk about any layer 2 or router hosts or router hardening configurations. We're going to talk about that if you guys come to DEF CON on Saturday afternoon at 1 o'clock. So if you want to see more about layer 2 attacks, like STP, DTP, VLANs, router configuration, how to harden your router configuration, I really welcome you to join us at DEF CON on Saturday afternoon. So basically, what runs the internet? This is the key questions. The key question. What you guys know, everybody knows IP, everybody uses IP, but what makes the core of the internet? Basically, the internet is running an external gateway routing protocol which is called BGP. BGP is the routing protocol that is used to exchange information between autonomous systems. An autonomous system is usually a company, an ISP, that has to work with other ISPs to exchange your routing information. The next key protocol in the internet is DNS. I mean, everybody has to configure DNS on the laptop, on the home PC, at work. I mean, without these two key protocols, the internet wouldn't be running. And if you attack them, well, you can not melt down the internet, but make sure that part of the internet is not working anymore. And also, BGP and DNS have been around quite a long time, and lately, we have seen that in all new recent technologies called that L2TP, V3 and so on, BGP and DNS are used. Basically, DNS is used to store information, like you will use an LDAP tree to put some information about email accounts. Well, on the network side, DNS will be used to store network-related information. BGP is then used next to that to distribute this information across the network, since most of the large corporate or ISP networks have to run BGP somewhere anyway. The other thing is on the internet, most of the vendors are using the same kind of hardware. So you have some really large vendors on the internet that are used, like you have Cisco, Juniper, and so on, and it's really limited number of huge routers that do the job. Also the software release, and you will understand why I'm talking about that later on, are more or less the same. That means everybody is more or less using the same software release all over the internet. And well, what is important too is all the people like you, network admins, sysadmins that run these huge networks and in the network operation centers. Like I said in the introduction, the internet has really become a critical infrastructure. If you did attend the first talk on the first day in the morning, it's really easy to understand or easy to get the impression that the internet is really the key part of the critical infrastructure in the US next to the power grid and so on. But basically in the late 70s, when the internet really became famous or really used out of academic universities and military stuff, everybody was trusting everybody. So the internet was really a nice place, nobody was doing anything bad and so on. At the moment, fights are ongoing all the time. So things haven't changed, but the way people use the internet has really changed. And when I was writing the slides, I was just thinking, oh, what's going to happen to the internet if one big company goes Chapter 11? And nobody at that time was talking about what's going on with MCI WorldCom at the moment. You have to know that a company like Unet, which is part of MCI WorldCom, is one of the largest internet service provider in the world. If that backbone goes down, I have no idea what's going to happen. In Europe, you have seen KPN Quest dying recently, but the network survived. Nobody did see some really strange things, but if some really large ones in the US are going to die, nobody knows at the moment what the effect's going to be on the internet. You have also the well-known Slashdot effect that used to kill most of the major websites, and even with the ones with distributed content. And Multicast has been around quite a long time already, but not a lot of people are using Multicast. There are a lot of best current practices. Usually when people come to us and ask questions, we just have to say, just have a look at this documentation, have a look at these slides and so on. There's a lot of information around how you should configure your network, do the design and so on. But people don't do it. Things are around, but people don't do it. You also have a lot of IETF and IRTF working groups at the moment that we'll list later on that are working on all these routing protocol security issues. The current type of attacks that you usually see on a network, well, the most current one is, or the most common one, so to say, is misconfiguration. Basically, some years ago, when somebody was doing something wrong in the BGP configuration somewhere on the internet, it could have killed part of the internet. Can it be in the country, on the continent base, or even worldwide? So this is really the most common type of attack. Nowadays, most of the large ISPs are really starting to filter what's going on and what's coming into the network and leaving the network. But this is still the most common attack. What you see basically all the time on the internet is some kind of DOS or DDoS with spoofed source address that are attacking IRC servers, some websites, some home users and so on. Basically it's just there's always a fight ongoing somewhere on the internet. And up to now there's still no way to do a reliable traceback to the source. And believe me, this is not going to change in the next few years. What people are also doing, all the network prefixes that are used on the internet, you have a lot of IP addresses and not all of them are affected to some ISPs. Well, some people just take them and use them for a short period of time to send out spam. This has been something that's happened recently. And people just use them, these IP addresses, put them somewhere in the AS, announce them when they are done with their, so to say, work. That means spamming or some kind of attacks, they just stop to announce them. What we are seeing at the moment, what starts to happen, is this advanced routing protocol attacks. You probably have seen some talks last year up from FX. This is really starting, and people are really starting to play with routing protocols. And they can basically make your network meltdown, start to make it unstable, start to announce no routes. I mean, everybody has seen that the MAC address yesterday of some of the access point change and this kind of things. People are always playing around anyway. So this is happening all the time. And what is kind of new that we have not seen really in the world up to now is rootkits. I mean, people really start to play with some kind of iOS releases, start to do new things, see what's going on. If they can play with a Cisco device or a Juniper device, like they could play with any other operating system. And for that one, I really recommend that you attend the next talk from FX about the embedded devices stuff. He's got some really nice things to show you. So BGP is the border gated protocol. The current release that everybody is running is version 4. Basically, it's clear text information exchange that's going on. On most of the BGP daemons at the moment running can be GATE or Zebra or any vendor implementation, you have support for MD5. So at least you can add some authentication to that. Basically, the BGP session are running point-to-point between two devices that are connected directly one to each other, or a kind of cross-link if you want to. But they can also be multi-hop between non-adjacent routers. That means basically that most of the implementations use the TTL of the IP packet to see if the BGP session comes from remote or is really local between the routers. I also have a copy of the BGP update message on the slides that shows you how the information is carried between the two systems. So this is kind of a high-level view of a network design. You have one of the autonomous systems that can be your company, the ISP you are connected to, which has a lot of core routers, and all of them have BGP or so-called iBGP for internal BGP sessions running between the routers to exchange this routing information. Then you have at the bottom two external ISs, ISZ and ISY, that are connected to me. That can be another ISP, another corporate network, one of your partners, where I have to exchange information with. So basically, if you follow the two red arrows, these are the points where you have to filter what's going on your network, especially what you accept, that should come in, and also what you send out to the network. I will show you some templates on how to do it. The risks, where are they? Well, basically, the risks are always at the point where you exchange information. So, in the US, you have some really large NAPs and some really large peering points on East Coast and West Coast. Basically, all service providers are there, are present, are connected to each other over some public infrastructure, usually some really big switches running Giga Ethernet in ports and this kind of things. Since the service provider also have a lot of new customers leaving and so on, that means that basically usually the filtering policy you apply over there is much more relaxed. So you will always filter what's coming into your network when you go to your upstream, to partners and so on. But on peering points, you just go more relaxed. Say, yeah, it's another ISP, you know what's going on, and he knows what's going on. He won't do anything bad to me anyway, so just leave it open, don't filter that much, because it's, yeah, too much work to do. So this is really one point where attacks are quite easy. We also have seen recently that most of the major peering points are located in some well-known areas. Like New York, you have this huge telehouse, you have the SF Bay area, and if somebody will go there and just blow these things up, well, this would be bad for a lot of ISPs and for the internet as a whole. The other thing you have to have a look at is your direct up and down streams. This is basically where you connect to partners, ISP, where you resell bandwidth, where you get bandwidth from. The interesting routers to attack would be the route reflectors. Route reflector is a device that is running BGP that is talking to all the other routers and is basically concentrating all the BGP sessions, does the route decision, and also sends information back to the routers. This is really kind of an interesting point to attack. The multi-hop configurations, where you have multiple routers in between your BGP sessions, are also interesting because it's there where you can easily play with man-in-the-middle attacks, especially if you own one of the routers in the middle. What is less likely? I don't want to say, okay, anybody can just go somewhere and try to kill something and make the internet meltdown, or this is not so easy to do, maybe it's even impossible. So if it's not easy to say, okay, we're gonna attack a router that's out there in the field, like 5, 6, 7 hops away and do something, because that's really not possible. The problem we have currently on the internet is that still nobody tries to match the network prefixes that are allocated to any customer from the original internet registries and the AS in which this information is routed. Yes, question. Excuse me?
Was it treated back in the old days so that people used to actually use prefix length filtering and originating checking?
Well, some of the ISPs are really starting to do it. Some used to do it for 3, 4, 5 years. But most of them, I mean, the larger ones do it. The real big ones, but the small ones, and don't do it. That's still the problem. You don't have any tool at the moment except some Perl scripts that get the information out of some database that do it. So some of them are doing it, but not all of them. That's still the issue. So before you go for an attack against BGP, you have to gather the information on how the BGP session looks like and where you can attack. So basically, to find out the eBGP peers, you can just do a forward and reverse trace route to get the information about IP addresses. about the routers. You could also use some ICMP messages with the route record option and get the information on IP address of the router and so on. What you can also use to gather information are these public route servers. A lot of ISP to ease debugging just have some of the core routers connected to these route servers to give them the information about how they see the network, how the routing is currently done. And there you can usually also gather some really nice information. What you can also do, especially on peering points, is just go for the adjacent IP addresses to yours. You get one IP address from the peering point, and you just have a look what's around, who is just before you, after you, and so on. You also have the IP address they use for loopback interfaces, which is usually .1.254 and so on. You also, if SNMP is open, which shouldn't be the case anyway, that's the door open to anything. So we have seen some providers running open SNMP with still the public SNMP community on it and so on. So this is really easy information to get together and to play with. Okay, for session parameters, I'm going to talk about it later on. So basically what you could do, the most stupid, so to say, attack would be just to synclude the port TCP is listening on. Most of the routers and implementation at the moment are filtering this out and don't react that much to it anymore. Depending on the implementation, you can also just go there and try to drop the BGP session. As soon as the BGP session is down, well, all the routing information gets lost and you lose some passes in your network. Depending on the implementation, you can just go there, send a reset, and everything will go down. In the most recent implementations, like the Cisco one and some others, you have to have a lot of information about the TCP session itself, source IP address, destination, port, your sequence number, and so on and so on. So at least this protects a lot of things. Is there a good chance that somebody can play around and come up with a BGP root injection tool? Yeah, probably. And we have seen some in the wild in the past. Are they working well? Well, not easy to say. What you have to do once you have gathered all the information is just try to inject this update into the BGP session. Can be with a man-in-the-middle attack, especially on the peering point switches where you can play around this app spoofing, since nobody usually is looking that on routers. You have to synchronize in some way or try to hijack the TCP session and get the information in. If the guys are running the MD5 option over that, it's not going to be easy because you need really a hell lot of information to try to find out the key. Or then you have to, what you can also happen is that you have to know about the configuration of the device because you already peer with that company or you have part of the information that always makes it easier anyway. What we have not seen yet, but what may come up, especially after you've seen FX talk, is there any security bug in the BGP implementation of some open source tools or commercial vendors and so on? I mean, this is something that people have not had a look at recently and deep enough probably. And everybody just thinks when you have a BGP session running, well, on the other hand, on the other side of the BGP session, you're going to have a router that runs BGP too, and it's from a commercial vendor, but you can just have any BGP implementation running, and you can play with it, especially if you take Zebra, for example. So what you can do is play with the BGP parameters, local preferences, the multiple exit discard stuff. You can play with the communities. There are really a lot of things to play with. The easiest thing is still to try to bring the BGP session down or to make it flap. If you do that, usually if you can make a BGP session flap 2, 3, or 4 times, you can be sure that most of the ISP is going to filter this one out for at least half an hour. So it's an easy way to black hole some destination if you can play with that. What is also interesting is that all the routers out there on the internet have more or less the same view of what's going on at the routing level. That means they hold most of the routers hold a full routing table with all the information how they can reach a destination. So if you just start to split up the information and start to announce some deaggregated blocks out of this, you can just eat up all the memory on the routers. So this is likely to happen, and some ISPs are now starting to filter this out and say, okay, if you start to announce some deaggregated blocks, we filter you out. And by doing that, yeah, what you can do is just direct the traffic to a black hole, direct it to a specific network to try to create a DNS service. You can create loops and so on. There are still lots of things to do in that area. We have been talking about TCP sessions hijacking. These are some old pictures from ISNs on TCP sessions that are coming out of a Cisco router. So they were time dependent in the past. They are still a little bit. You see on the right hand side that the information is concentrated somewhere in the middle, and that you can start to do things there. So there are ways to try to inject things from remote. So now that you have talked about all the attacks, what should you guys have a look at to see if something goes wrong? Basically, you should always have a look at the IS path and see if the IS path has changed. The IS path is the way or the hopes you have, the AS hopes you have to go over to reach destination. If that one is changing, well, usually it's normal because some ISPs may be down, it takes another route to go to that ISP and this kind of things. But if it's really changing in a strange way, well, you should have a look at it because this is not good. Also, all the information you receive from other ISPs, you receive a lot of routes, but to some destination, to some of your key destinations like root servers, DNS servers, and so on, you should always watch it, see what's going on. If somebody is not trying to direct traffic to some other destinations. If you also see, and some people are really trying to watch that at the moment, if some autonomous system is announcing a more specific route or route just like for 5, 10, 15 minutes, usually it's a misconfiguration when they did something like implement a new customers. But a lot of people, as said before, are using that to do as a source of spam. To send, they just be there, do it, and then they are gone. And there is no easy way to track them down. Also, and that is not easy to do either on routers, is on all the internet exchange points, watch the ARP changes. If some things are changing, usually ISPs don't change the routers every second day on a peering point. So if you see some ARP changes all over the time, there's probably some things going on over there. And also, and people don't do that often enough, BGP, when some things are flapping, changing and so on, put things into the logs. So have a look at your log files to see what's going on there. So, and the origin AS prefix mapping, as discussed, has already been implemented by some providers, but it's not implemented by most of the providers. So there's still a lot of things to do in that area to try to fix this and really make sure that you announce what you are allowed to announce. On the filtering policy side, you should never accept to only have /24s. And /24 and CIDR notation is like just 3 times 255.0. So usually large ISP announce aggregated blocks that are /16, /12, or so on. If somebody tries to split up this or deaggregate these blocks, what's going on is that you will eat up all the memory on the routers, and the router just dies, or a BGP session is going to die. So always filter this out. What you can also do, especially towards customers, is to use the maximum-prefix command. Basically, what you should receive from your upstream is a full route information. At the moment, we have between 110,000 and 140,000 routes that are carried inside BGP. So if you just see to start to see 150, 160, 2,000, there's probably something going wrong somewhere. Like with IP ingress and egress filtering, you should always filter what the customer is sending you and what you send to the customer. And you have also to filter all these aggregated and non-aggregated blocks and things that have not been allocated yet. This is really important. Yeah, some list of what you should always filter out on the IP level. I mean, everybody should never carry like RFC 1918 information, 0.0.0, and so on. I mean, this is just a list to show you that if you see this kind of IP addresses on your network, somebody is somewhere playing around with some kind of things. So you should always filter this out and try to at least not announce it towards your upstream or towards your customers. This is just an example how to implement that with access lists. So if you want to filter this out at the IP level, you can implement that with this kind of access lists. Don't forget that on the route, an access list usually used for filtering uses a lot of CPU. If you don't use this kind of turbo ACLs features like on the 72 or 6 routers from Cisco. What you can also do, if you don't want to filter it out and drop it or log it, you can route it to null zero. Null zero is like dev null on a Unix system. So if you do a route to that, it's just going to drop the packets at the line card level on the GSRs. You have the common name on the Junipers is just discard. Yeah, security measures. As always, log all the changes, especially about when BGP has sessions of flapping and this kind of things. What you can use to protect BGP next to MD5 would be to use IPsec. But you need the IPsec feature sets, not easy to configure, you can mess it up, not a lot of ISPs are using it, so yeah, you could, but I haven't seen anybody do that yet. MD5, you should use it anyway, and force your peers to do so. What you as said before, you have to filter what's coming in, what's going out. What you can do also for the BGP session is not use the physical IP address of an interface, but use one of the loopback interfaces, so you can try to hide a little bit the IP addresses you are using to establish the BGP session. Loopbacks are interesting for that, but not only for that, because loopbacks are independent from the physical interface status. They are usually always up, so to say. If you start to filter things out, don't forget that you could black hole yourself, as usual, like with this personal firewalls. Would you like to block this destination if she port scans you? Yes. And in the end, you end up not being able to reach some destinations. You should do the same, especially you should never filter out things towards road servers. If you cannot have DNS lookups work anymore, well, anyway, you're going to be down. So don't forget that you should filter this kind of things out. What is important is to filter things out, but is also to secure your router. And we're going to talk about that at DEF CON. Say, by default, like any or most of the operating systems at the moment, since there is an operating system running on a router, you should filter things out and make sure that the services you don't use are deactivated. This is really important. This is an example for the BGP configuration. If you have some questions about it, why we did it that way, or if you want us to explain it to you, what the different commands are, just come to us after the conference and we'll be really happy to show you and to explain you why we did it this way. So what's going on with BGP? BGP version 4 has been around quite a long time. And people are now starting to think, okay, what should we do to start to make it better? You have some BBN working group that is working on SBGP for secure BGP. They are just trying to add this, it's not AAA, it would be AA. That means there's no accounting part in it. And really try to verify this ownership and the relation between the IPs, that is the network prefixes, and the AS, these network prefixes are used or carried in. So this is really the first step into that direction. They also try to implement signed update messages and so on. The only problem is that it's really a major change for a lot of things. It's a major change how you do your work. It's a major change for the BGP implementation on routers. It's a major change for all the databases around the world, like the RIDE database, the ARIN database. So there's still a lot of things to do, but at least there's somebody working on it and some recent draft around, and even some implementations that you can give it a try. So this is I think the good direction, but in my opinion, it will at least take 3 to 5 years to see that really implemented in by commercial vendor and really used. Yeah, as said in the inclusion, there are really a lot of working groups. Yes. Yeah, so the question is about SBGP, the implementation itself, and what you have to do with your partners. So just let me get back to that. So first of all, the BBN guys did a proof of concept code, like you said, modified implementation of GATE. You cannot just go and pick that one and put it on a hardware device, because even if iOS is a kind of Unix-based system, you could, yeah, cool. Cisco still has to implement it. So this is not done yet. So I don't know of any hardware router that implements SBGP at the moment, except this proof of concept code. For the partner side, SBGP has to be deployed, so to say, everywhere and by everybody to make it work. It's like the same with ingress and egress filtering. If you have some networks that don't filter what's going out of the network, like the guys over there in China, Taiwan, and so on. I mean, everybody can do it. If you have some 5 person that do it, you have two options. You filter them out everywhere, just say, okay, I don't want to talk to this network and receive any traffic from this network. Or then you have to push everybody to do it. Or then you start to have, like some people discussed it some years ago, a two-class internet, where you have the validated ISPs that really do their homework, they have the best current practices, they're on SBGP, they make sure that what's going on, what's coming in the network, going out, is really filtered and so on, but this is not going to happen in my opinion. Is it okay? Okay.
Most of the routers we want in the back end is have the routing is basically general purpose machines now. Like in a Juniper, there's basically a menu architecture box sitting there for routing in a variety of Unix essentially. And so when you centralize implementing these things, the horsepower, having to the horsepower of each router at their should increase as you go along. As you go to handle these things. And I know that Cisco next generation also is simple to work with.
Yeah, but nobody has seen iOS next generation up to now, so really waiting for it to see it. Okay, let's go ahead. There are a lot of working groups at the moment that started recently to work on all these routing protocol issues, so to say. The latest one that I really recommend you go to the mailing list, because there are really some nice information about it, is the RPSec one. So just have a look, go to Google, look this up, and make yourself part of mailing list, because there are really some really interesting information that are going over there. So just going down to the forensic part, up to recently, nobody was really looking at who used to announce which network in which AS. This is changing. Some people used to do that just to gather information about, for some papers, publications, but people can use that at the moment for forensics to see, okay, which AS used to announce this prefix that sent me some spam in the past. This is something that people are working on at the moment and that are really interesting. So going quickly to the IGPs, the Internet Gateway Routing Protocols, the most used ones next to RIP, RIP means rest in peace anyway. So is OSPF. OSPF uses multicast traffic. So basically, in your network would be much more easy to inject any LSA. An LSA is a link state advertisement that contains routing information, status change, and so on. So it's much more easy to inject it because it's multicast. All the routers usually build what is called an agency between them and some designated router. So you will see that designated routers and routers that are used to exchange information with other OSPF areas are really interesting, because like for BGPs, route reflectors, they concentrate all the routing information and are the link between most of the things. What is interesting in OSPF is that the designated routers and backup designated routers don't preempt. That means that you would have, if Cisco's implementation at least, that means that if you want to take over the role of a DR or BDR, you would have to kill it by some way to make sure that you're going to get these sessions towards you. On the routers that are links between areas, that means an ABR, area border router, or ISBR, an autonomous system border router, that carries real information between your network and some other network or some other areas. These are really good targets to play with, because they are really the ones that contain all the information distributed, and everybody trusts them in the network. There's really, like in OSPF and ISIS, every router just trusts the key routers in the network. Recently, some guys have proven that you can replay even MD5 LSAs because you don't have enough information in these packets, and you can use that to inject new routes as usual, to break agencies, to try to max age the things out and this kind of things. So if you have somebody internal on your network that can mess up with your OSPF information or ISIS information, you are more or less dead. And everybody knows that trying to track down something on layer 2 is really not easy. So make sure, and this is really important, that never ever run a routing protocol towards workstation, partners, customers, and so on. Filter things out on switches, filter things out on routers. This is really important. some of the security measures you have to use, like just said, is you can authenticate OSPF by using MD5. You should do it because it really helps. It filters a lot of things out. If you want to turn your, so to say, broadcast or multicast network into a point-to-point relation, you can turn your network into an NBMA one. The thing is, you have to enter one neighbor statement per router you have to discuss with, which it's like filtering MAC addresses on switches. Yeah, you can do it, but on the operational side, it's not easy. Some other things, yeah, as usual, the interface that shouldn't run OSPF, you should filter it out. You should log changes, and you should filter what's going out and in your network. The only thing is you cannot filter on every OSPF router. You can only filter out on ASBRs, what should enter the area and what should leave it. Okay, ISIS. ISIS is quite an old protocol. It comes from the Aussie world and has been around for quite a long time. And at the moment, some vendors are really pushing it hard because they just recommend it if you want to use MPLS or any kind of traffic engineering in your network. The good thing or the bad thing for ISIS is that it doesn't run on top of IP. OSPF does. So it's not, you have really to have access to data link layer to inject things. And you cannot, that basically means that you cannot inject things from remote or some hops away. This is not feasible. But it also means that since it's layer 2, there are really no tools or IDSs at the moment that watch for that. So if somebody starts to play with some layer 2 kind of things, can it be app spoofing, man-in-the-middle kind of things related to that? Or with ISIS, I don't know of any tool that currently tracks that down. Like with OSPF, MPLS fruits, LSPs. LSPs have nothing to do with the label switch path of MPLS we're going to talk about later on. The difference, one of the big difference between OSPF designated router and OSPF designated router is that the ones in ISIS do preempt. So if you have a new one that has a higher priority, it will take over the role of the other ones. So it's like a little bit with HSRP. If you have a new router with higher priority coming in, you can really force the HSRP session, so to say, or the virtual IP address to move to you. Attacks, yeah, basically they are the same as with OSPF. They are more complex or more easy depending on what you want to do because they are not running on top of IP. You have also an interesting flag in the LSPs that are exchanged between the routers, and that is the overload bit. That one can be used by the router to say, okay, I have too much things to do, please direct the traffic over some other routers if possible. That would be a way to direct traffic to you by spoofing them and saying, okay, all the routers except mine are overloaded and can't carry the traffic anymore. As usual, the security measures are the same as with OSPF and BGP. Log the changes and use authentication. The difference between OSPF and ISIS is that with ISIS you can use it at the interface level, the area level, or the domain level. So you can really also authenticate all the exchanges there. And recently most of the vendors and open source implementation have had an HMAC MD5 support, which is using a TLV54 as the field where this information is carried. Okay, this is all for the BGP, ISIS, OSPF part. I hope it has been clear. If you have any questions, just come to me afterwards and we're going to talk about it. And now I'm handing things over to Sebastian. He's going to talk about the DDoS stuff, NetFlow, MPLS, IPv6, and well, talk to you later.
Okay, hi. So yeah, as Nico said, I will talk right now about DDoS detection. So I will, for DDoS, we will mainly concentrate on the network side of DDoS, not the impact on the server, but more what you will see on the network and what you could monitor or do to prevent or block the denial of service attack. So one of the very useful tools we are using is a NetFlow from Cisco, which is an accounting tool. This tool is exporting data about traffic going through the router, like autonomous system, IP flow information, protocols, and so on. Those information are regularly sent in clear text to gatherers that will collect all the information. What you have to know is that NetFlow will only capture incoming traffic on the router interface. So if you want to see all traffic, you have to capture the flow statistic on all the interfaces on your router. So to have it running, you need to enable a CEF, Cisco Express Forwarding on your router, or distributed CEF. So it works with iOS 12, version 12 and up. You have several versions of NetFlow. The main one is version 5, where you have the BGP information and sequence number in the flow packets, and version 8, which is right now more or less only supported by Cisco, which is able to aggregate data information, which is really interesting for large network with a huge volume. On the biggest router, like Cisco routers above 7,000, 7,200, 7,500 or GSR, you won't have any CPU problem, because this is done on the line cards or on the interface. So you can really activate it without any problem. So you have an example of the configuration you need to set up on your router for NetFlow. So it's pretty simple. You just define which version you want to export. So the example is for a Cisco router. You define the destination of the flow information, and you have to activate flow export on each interface. So while you're on the router, you have a command show IP cache flow to view and go through the net flow information on the router. So once you are gathering all the information, you can start doing some statistic analysis of your traffic. So depending what kind of network you are running, if you have a small or large ISP or corporate user, you will have different traffic pattern. For example, for us, we have mainly TCP traffic, like 90%. You shouldn't have too much UDP traffic, except if you have a streaming customer or customers or users. And you should really get a low percentage of ICMP and IGMP packets. So you have two graphs, which is an example from a university done with the flow scan tool. So in the middle one, you see that you have a big peak of incoming traffic. So probably at this time, something was going wrong. So the good thing with NetFlow is that you have traffic information. You know that you have exceeding boundaries, which is not normal, but you can also have a look which protocol is using these boundaries. So you could correlate that to see if it's normal usage or something which is wrong going on. One thing you can also monitor is on some network you have most of the packets are matching a certain size. It can be 64, 128. It really depends on your network. You have to look at it. And if you see that the average size of the packets is changing, yeah, something is probably going wrong too. So the two main tools you can use is IRD tool to graph a NetFlow. You have a set of free and commercial tools for gathering NetFlow. We are using SafeLoad from Kaida, which is working not too bad. And then you have also tools like FlowScan to represent the data. On a multi-layer switch, you have to be careful. It's not working exactly the same as on a router. Like you will only see the destination information of the packet. You won't have the source address. And if you have enable the full flow mode, you will have performance issue with the supervisor engine version 1. The configuration is then pretty straightforward. If you don't have any Cisco router or any equipment at all which is able to produce NetFlow information, you can use NTOP. NTOP is able to export NetFlow or gather NetFlow information. So you just put Unix box on your network, capture all the traffic, and you will be able to export the NetFlow traffic. So another thing you can do to prevent again DDoS is to be able to block spoof packets or to filter out what kind of packet you are allowing on your network. So a useful feature on the Cisco router is Unicast RPF. So Unicast RPF in Unicast RPF mode, the router will check for each packet if this packet is coming via the right interface or if it's a legal packet at all. So you have two modes. The strict mode, as I said, is checking that the return path for this packet is the same as the incoming interface for the packet. This is working fine, except if you have multiple entry on your network and if you have asymmetric routes, because the packets could come via an interface and go out via another router and another interface. In this case, you should enable the loose check. In this mode, the router will only check that the prefix from where the packet is coming from is in the forwarding information database. Okay. So to activate Unicast RPF, it's really simple. In strict mode, you can set up access list to log rejected packet. Yeah. Okay. Another thing that can be useful, depending on also what kind of traffic you have, is rate limiting UDP, ICMP, and TCP SYN packets. So mainly what you have to do is to set up a rate limit instruction on your interface. So it's like the first part of the configuration. And you apply an access list on this rate limit. So depending what kind of traffic you want to rate limit, you are just free to do it the way you want. Before doing that, be sure to have a correct analysis of your network traffic so you don't break anything. Like if you have a lot of streaming customers, if you rate limit UDP, then you may have a complaint from your customer and so on. Another feature that you can find into a Cisco router is TCP intercept to filter out TCP uncheck. So this can be good. It's interesting feature. I'm not sure if the router is the right place to do that. Definitely, it's probably not the right place. Anyway, it's available. So you have to know if you enable this feature, the router will go from CF mode to process switching, which has a big performance impact. So if you are running a heavy loaded network or a low-end router, it will probably won't be able to handle that. What will happen if something is going wrong? It will just block the source of the packets. So yeah, it can block some attacks. Yeah. What I will talk about now is what you should do with ICMP. So you have different schools out there. Some people let ICMP totally free. Some people want to restrict it. Okay, ICMP can be used to probe your network, to gather information, even attack some of your system. So I won't get into the debate what kind of ICMP message you have to block or you shouldn't block. It's your decision. What you have to know is that at least a lot of our customers we experience, they just think that ICMP is used for ping, and that if you filter it, you will also break pass MTU discovery. So really be careful before doing that. So one thing you have to think about is detecting the denial of service attack is one good thing. Then you have to be able to react to block it. You have to know that once you are under attack, it's really hard to do some live modification because most of your equipment will be overloaded, and any single modification you can do, like enable debugging on your router, whatever, will just kill the bugs. So what you should think about it before and have measure and the configuration ready, and you just have to activate the feature to block the attacks. When you have a DDoS attack, the main thing you will have to do is stop the attack, so block the source of the attack. You have several ways of doing that, and which are really simple without any performance impact on your equipment. So the first one we'll present is redirecting the packet to null zero, which is a dev null of the router. So to do that, you just add a static route for an IP address, which you can take it, for example, from the testnet network, and route this IP address to the null-zero interface on all your routers. So you have to go in every single router and do that. When you are under attack and you have identified the source packet of this attack, the only thing you have to do is on one of your BGP router, like your route reflector or a router you want to use for this purpose, you just have to advertise that the next hop for the source address is a route that you have set up to be routed to null-zero. So immediately all your router on your network will drop all the packet coming from this source IP address. So the good thing, it's easy to do when you're under attack, doesn't have any performance impact, it's just one command to type on a router. You have to be careful when you do that not to redistribute this information to your BGP peer, like your upstream or your peering partner. So for this, to distribute this information, you can use a private IS, or you use communities that will block export of this information. So here is the same diagram as before, like Nico showed you. So what will happen is when you are under attack, you go just on the routers, like the one on the upper right corner, and you will just set up the next hop for the identified source IP address that will be propagated to all the information, to all of your router. So when a packet will come from this IP address, it will be dropped. This is fine, but it won't work if you have a large number of incoming of source address used for the attack. So, yeah, it has some limitation. Another way of doing that is instead of using next hop is to transport the information to each router is to use communities and rate limiting. So what you have to define is a community that will be used for identifying the network you want to rate limit. So this is a configuration example that we provide. And when you have identified the source address of the attacks, you can use, for example, the quality of service ID to mark the packets that have to be rate limited. Then you have to set up in your BGP policy a rate limit for those packets. So the advantage is that you won't drop all the packets, you will still allow part of the traffic to go through, and this information can be used for analyzing the kind of denial of service you are under, and so on. Another thing you will probably want to protect is a worm. Most of the time the network itself is not subject to worms, at least so far we haven't had any example, but you could use your network to help protecting against those worms. So how you can detect those worms? Basically you will detect an abnormal traffic repartition, like increased number of HTTP or SNTP sessions, which was the case for the Code Red and NIMDA attack, for example. So there is another feature provided by Cisco, which is NBAR, which is a kind of IDS, but with a lot of limitation, as you will see. One of the main issues you have is it has a huge performance impact on your router. And the TCP uncheck is done by the server before the router checks the content. So when the router will block the packet if he has detected some incorrect content, you will have a TCP connection hanging around on your server. TCP session, yeah. So the limitation of this technology is that you can only support up to 24 concurrent URL, host, or MIME type matches, which is really low. So except if you are running a small network, well, you cannot use that. Another big limitation, it will only match the first 400 bytes of the packet. So if the attacker knows that you are using NBAR, they just have to pad the packet with whatever they want to go around this protection. It will also won't handle fragmented packet. It won't look inside HTTPS packet, which is normal because it won't decrypt that. And also a limitation, it won't investigate packets which are originating or sending to the router. So it won't protect the HTTP server you are running, for example, on your router for the management. And it doesn't support Unicode. So as you can see, there are really a lot of limitations, which doesn't really make it useful in real life. Yeah, never seen so many people using it, and yeah, we are not using it either. Yeah. Now, there are a lot of research going on in the denial of service and warm field on both sides, like black hat and white hat. Sorry. So the community is trying to set up a set of protocol technology to identify the source of those attacks, because most of the time either it's a spoof packet or using a broken network which shouldn't belong to anybody. And one issue you have, even once after you have identified the attack, blocked it, if you want to trace back to the source, it's really hard. So I will present briefly all the different technology or protocol which are under development. So ICMP Traceback will be used to identify or to get a view of what's going on in your network. So mainly what you will do is get a sample of your traffic, like one packet over 10 or 20,000, and send this packet to the destination. So the destination of the traffic will be able to have a sampling of the traffic coming from all the routers on the path. If you have a large denial of service, for example, with a large amount of traffic, you will be able to see from which router or through which router those packets went through, and you will be able to trace back to the originating network. So this will only work if everybody is using that. Definitely, because as soon as you will have a network somewhere which is not using this technology, you won't have any information, and you will lose track of the attack. IP Traceback is the same ID, but instead of using ICMP packet to the sent to the destination, they will store the information inside the IP packet which is transported. So they are using the IP ID field on the IP packet. So it's a nice idea. The only problem is this field is quite small, and it's not clear how much information you will be able to set up in this field, and will you have enough information at the end to be able to trace the source of the attack. The good thing with this technology is that you will have the information for each individual IP packet, so you will be able to catch even the smallest attacks. Multicast, which is something a little bit equivalent to NetFlow. The idea is to have like traffic statistic information on all your devices to be able to analyze the traffic on your network. Yeah. SPI is a technology which the main idea will be to store on each router information about the traffic. So everybody which is in the same authorized area will be able to query the router to get information. So once you have identified your attack, you can go to each router and see and ask the router to see what kind of packet he saw and pattern of the traffic. The only problem is that you have a limited amount of memory on your router, on your routing device, so you won't be able to store so much data and only for a short period of time. So this is only usable during the attack. Pushback is a technology which is the aim is to limit the effect of denial of service attack. So the goal is to send back to the network rate limiting information to be able to slow down the attack at the source. IDIP is is not a protocol, it's more a framework. The intent is to do a little bit like for IDSs, have a framework and protocol to correlate, to store and correlate information, to be able to detect incidents and respond to them. And the last one, host identity payload protocol, is the idea is to set up a new kind of protocol, a new namespace with authentication to be able to identify every host on the network. This will only work if everybody is using that. Okay, center track is idea is to develop a parallel network that will carry interesting packet detected by the router to do forensic analysis. So this will be used for detecting the attacks or to analyzing the attacks. So all of the techniques are very nice. The main limitation is you will have to install that on all your network equipment. So usually on a router you don't have so much CPU power, you have not so much memory, or the only memory you have is used for the routing stuff. So here you will have a lot of limitation. Another problem is that it will introduce a lot of change on all your network infrastructure, like new software on all your devices and deployment all over the network, all over the ISP. And for most of the IDs, everybody has to cooperate and use the technology to have it really efficient to trace back and block an attack. Okay, on the Black Hat side, there have been a lot of research done. Some of it have not been made public because it's really hard to protect, and a lot of ISP or big network are not ready to protect against them. So as we saw in the past, really easy or simple DDoS can really blow up networks. So some people are just keeping the information they have, or even the IDs, because the risk is too high to permit people to just blow up the whole network. So far the worms were quite simple or stupid, just brute forcing like the NIMDA encode rate, not even trying to identify what kind of server they are connecting to. But yeah, it's quite efficient because you have so many vulnerable hosts in the field that it's working. Yeah. And mainly all the attacks are targeting the most used systems, so it's mainly Microsoft with IIS and Outlook, which I would say is the most efficient because those systems are not as well protected or patched as other systems on the internet. So all those attacks could have a huge effect on the stability, and as we saw for the previous attacks, it's not so hard to blow up big networks with worms or denial of service. So in the trend for research, we are seeing more and more investigation or research on the router field, because what is best to generate DDoS denial of service attacks than a router able to generate millions of packets per second. Like if you can use a GSR to generate your denial of service, with one box you can blow up several networks. So routers will more and more be used as a source for those attacks. And the attacks will also be more complex and intelligent. This means identifying more closely the targets they want to attack, and also more distributed. As Nico said, there are also more and more use of non-allocated blocks that will just appear for an attack, be used, and then disappear, making it hard to trace back the source of the attack. Now I will finish with a few information about MPLS and IPv6. We had a look since 1.5 years about MPLS, because we are wondering, okay, this is a nice technology, there is a lot of marketing going around, more and more people are deploying this technology, so what are the risks and what could you do with it? So for MPLS is multi-protocol label switching. So the idea of MPLS is to be able to carry network, all your network over an IP network. So MPLS is working by adding a MPLS label in front of the IP packet to identify the VPN in which the packet is transiting. So each router on the path belonging on the MPLS network has a table for which describe all the VPN on this network and what are the destination for all the VPN. So all the labels on the MPLS label are only a local meaning are rewritten on each router depending on the local routing table. So what kind of service MPLS is providing is mainly a kind of virtual circuit. So MPLS was developed for traffic engineering and routing, so you have no security within this protocol. The traffic is not encrypted, not authenticated. So it's more or less equivalent to other layer 2 protocol like ATM and frame relay. The main security within MPLS is the core of the MPLS. This means if you can get into the core of your MPLS network, you are able to do anything on your network. This means change the VPN, change the packet, the routing, and everything will be transparent for the user. And with MPLS, you have to trust your MPLS implementation and your service provider. You have no way to be able to check what's going on. So if you want to secure the traffic going over MPLS, you should use other technology like IPsec to secure traffic. As I said, the VPN are only a routing feature. So if there is no, the only thing you have in the router is a different routing table for each VPN, and depending on which VPN the packet is belonging, it will use a different routing table. Okay, that's a good. So the question is for security, recommend to use IPsec. So why use MPLS at all, and what could be the advantage of MPLS? So I totally agree that if you only want to do security, you don't need MPLS. Now, what MPLS can bring to you is if you can carry several virtual networks over the same IP backbone. So you have a lot of internet providers like carrying over the same IP backbone, like GSM network, internet network, and other corporate network. So MPLS IP network is more to view as an ITM network when you will carry over it several networks. And Cisco is developing new technology, so you will be able to transport layer 2 over IP. So you will be able to transport your voice trunk or your SDH line over an MPLS VPN. So MPLS is more traffic engineering and tool than a security protocol than a security protocol.
Yeah, I agree with you. If you see the MPLS, they have lots of features on traffic engineering. That's fine. But my personal opinion is the MPLS VPN is misleading.
Okay, thanks. Okay, so what kind of attack could be done on the MPLS network? We have identified mainly two types of attack. The first one is to inject MPLS labeled packet on the network. So this means if you can inject the packet with the right MPLS label, well, you just can define in which VPN your packets which VPN your packets belongs to. So the only protection you have is that the MPLS edge router are not accepting MPLS label packet. This is a default configuration on Cisco, but yeah, this is as secure as the implementation. If someone finds a way to go around that, then you will be able to totally inject the packet. Another way of playing with MPLS is to play with the signaling protocol. MPLS is using BGP and ISIS to propagate VPN information. So if you can attack the BGP or ISIS information, like inject routes or destroy some routes, you will be able to change your VPN topology. And the worst thing is that when you do that, it's so complex and you have so many information that nobody will notice that you have changed the VPN for routing it toward yourself. Yeah. Another thing, another feature which is really interesting in MPLS, and it's really scaring. MPLS is trying to be as resilient and as good as other layer 2 protocols. So they are trying to have a sub-second, so under-second route convergence and traffic redirection in case of failure. The bad thing about that if you can interact with the MPLS network, you can force rerouting of the packets without anybody noticing that. And it's pretty simple. You just have a few signaling packets to inject on the network, and you will be able to change totally the topology and the routing on the network. So so far the main recommendation we can do is check your configuration on all your router to be sure that nobody accesses it, that your routing protocols are protected. And definitely you shouldn't start your MPLS network on the customer equipment. It should be only on your equipment. So don't put MPLS on the router sitting on your customer, because if you have physical access to the router, he has access to MPLS network. Yeah. Okay, and to finish, we are running out of time. There's a small slide about IPv6. So I won't get into detail about IPv6. Mainly what you can expect with IPv6 is during the transition between IPv4 and IPv6, you will have a lot of gateway and between those two networks. And we strongly believe that those gateway will be a nice point to attack, to disrupt or to inject traffic into the networks. Yeah. Okay, so you will find on the last slide a set of publication about internet denial of service and worm activity trends. So you can go through them, they are quite interesting, and they are just showing that this activity is more and more increasing, and we are expecting much more in the future. Okay, so you will be able to find this presentation online on our website. We will put it online today. And you are free to ask any question. Okay, thank you. So it seems it's time for a break. So.